Fine. In this particular session, we'll see about sets. What is a set? So when I talk about a set is a collection of unique elements. Unique elements means if there is repeated values, it will be shown only once, distinct value. A collection of multiple, just like we had a list and tuples, it was having a collection values, but there was no concept like unit. Like I can have Sadiq many times. It was allowing me to have. I can have a particular number which has been repeated many times. There was no objection. It can have it. Multiple values of any type, any this one. But in the case of set, it says there's a collection of unique values. Okay. Fine. Now, set does not follow sequencing. Sequencing is what? When you store the values, Sadiq, Ghana, Sarah, Praveen, so we are stored in 1, 2, 3, 4. So when you try to read, also it is going to be the first value is Sadiq, second value is Ghana, the third value is Sarah, the fourth value is Praveen, okay, fifth value is Jacobs. It was reading one after the other. Okay, the same sequence as we had stored. But here in the case of set one, what happens is you store values in a particular sequence, but when you're trying to read, you'll never get in the same sequence. It has just always been retrieved in the different sequence. Okay, so they don't follow any kind of a sequencing concepts. Since they don't follow the sequencing, they don't support indexing also. Okay, since they don't follow the sequence, so today, if I use the index 2, that is the third element. So next time when you iterate, okay, in that third element, so it might have a different value. Okay, so instead of giving this kind of wrong answers, they don't support indexing. We cannot use a square bracket in an index number to read the values. If you want to read, you read everything. Okay, you cannot partially read the value from the sets. It uses the hashing technique. There is something called a technique when you're trying to read the data. Okay, so this is a hashing technique to read the data it is used. So it uses a hashing technique which improves the performance for fetching the data. Okay, so that means here what happens is, okay, sets are mainly used when you have very large amount of data and here I just want to read the complete data. Okay, so in that case we can use it because it uses a technique called as hashing. So this hashing technique uses, the hashing will improve the performance when you're fetching. So that means they don't follow a sequence one after the other. It is just rushing out. It's something like emergency exit. When there is an emergency exit, what happens? Just people run out. Okay, or I can just say an example like in the morning school time when people are getting in queue. So they have an assembly. After the assembly, they have to get into the classrooms. So they have to follow the queue. They have to pass in the queue. It takes some time. Like everybody has to go in a sequence into their respective classrooms, and they have to get settled. Now, after the class hour is over, evening time, and they have to come out. Okay, what happens? As soon as the bell rings, everybody rush out. Is it? Here, what happens? It's like a survival of the fittest. The people who have more faster, more energy, who can push everyone and they can come. So they come out first. The people also come out, but might be little this one. But at the end of the day, what happens? The school becomes empty in less amount of time. No? Okay, so something similar to this. Here, when I have a group of values, when you want to read the values, it doesn't follow any sequencing. It is not formal. It is completely a casual thing. Okay, we just say, I just want to immediately read the values. Okay, it just picks whatever the value comes in hand, it just picks the value and just gives it. Okay, so this is much faster than a list and the tuple when it is fetching the data. Okay, and now to define the set. So we have seen with a list was a group of values. We used a square bracket. We saw with a tuple, again it was showing a group of values. We used a round bracket. Now what is the leftover bracket? Flower bracket. Okay, the curly braces, what you see. So that means sets are defined within the curly braces. Flowery braces, or okay, what is it? Flower bracket or flowery brackets. As the curly braces of flower brackets. Okay. Now let us see how do we define a set. Let me comment off these things. Yeah. Now let me define a set. So to define a set, as I said, like so we just need to put something in the curly braces. So I can just have some values. I'm just randomly giving the values here. Okay, whatever it comes into my mind, I'm just typing this. Let me repeat a value. Right? That's it. I have a set. Now you want to know what type of S it is. I can just say print. I say type of S. So this is going to be your set. It belongs to a class set. Okay. See, in Python, we don't explicitly define the data types. Okay. It assigns automatically based on the type of values. So when it is a group of elements that iterable, it understands based on the type of brackets that you're using. Fine. So it is understood that it is a set. Now let us try to read the set. So I just say print and I set S is my set. So I'm trying to print. So you can see we have one. This is my actual set. This is my actual set. And you can see I have print S is printing like this. So we have one. Yeah, one. You can see next is 45, but here you're getting 75. Okay, so first value is read first, 0.2 + 75. Then third is reading as 45. Either it can be this 45 or this 45. You can see 45 is written twice, but here it is written only once. Okay, 78 is there, then 23 is there, 89 is there. Fine. So, but it is not following exact sequence. That means you can see 75 is coming. Now, next time when I run this program, you can see every time you run, it might not follow the same thing. Like if I just add some values here. Is coming. So it doesn't follow any sequence. And the other thing is you can see the value which has been repeated. Like example, 45 is repeated 3 times here. But you can see it has been shown only once here. Okay, so if I repeat any value, so I just say might be like 78, let me repeat this also. But you can see 78 also is given only once. Okay, so that means those are group of unique values. Even if it is repeated, it will be shown only once. So, and it doesn't follow any indexing. Okay, so it doesn't follow any sequencing. Since it doesn't follow any sequencing, if I pass an index, I'll get an error. So if I just say S of 0, no, this can. So sets doesn't support indexing. So it is used, okay, when you want to just read the data. So where, so here one thing is, you want to read the complete data. Okay, I don't want to read the partial data because it doesn't support indexing. In the case of tuple, okay, we can read only a selected amount of data. We can do a slicing. It doesn't support any indexing or slicing. So you want to read everything, so we use sets. Okay, fine. Clear? Now, where you have heard about sets before? In arithmetics, sorry, in the geometry, no, we had the sets, union, intersect, except or minus they use say. Okay, so a set is like again a group of values. When we have two sets, okay, when I say union, it gets the value of the first set as well as the second set. But whereas in the case of common values will be shown only once. That is what happens, no? The similar kind of operations we can do with the help of this set also. Okay, so we can have a union, intersect, and difference. We can do this. So we'll just see how do we do this. Now let us have a simple values. Let me just say set is equal to. Okay. Let us have a simple values here. 1, 2, 3, 4. Okay, and let's say this is my set 1. Okay, I just say set 2 is equal to, I just say 4, 5, 6. Let's say 3. Fine. Now I want to read set 1. What I just say is set 1. So this is going to read the value of set 1. Okay, but if at the same way, like if I try to read the set 2, yes, this is going to read the individual set. This is my set 1 and this is my set 2. Now I want to read the common values, what is there in both the sets. Okay, so in that case, I'll just use like this print S1, okay, and we use a pipe symbol for the union operator S2. So when I give it like this, you can see the common values, what is there in both. 1, 2, 3, 4, fine, 1, 2, 3, 4. Okay, and you can see it is giving only 5 and 6 because 3 is already there, 4 is already there. Okay, and you can see here the values were 4, 5, 6, 3, but it doesn't follow any sequencing. Clear? So what is this? This operator is representing the union. union of sets, right? Union of this is here. Fine. It combines the values of both the sets. So if I see if it is repeated here, take an example like we say 1, 2, 3, 4, comma 3 or 2. Now in the case of set 1, 2 is being repeated. Okay, but in the final output you can see in this 2 is single, here again 2 is only 1. Okay. Now you want to see only the values which is common in both. Yeah, let us see. I want to see the values which is common in both. Here we have this thing called as a intersect. Okay, intersect is the data which is common in both the sets. So it will be shown. To do an intersect, we write it like this. Intersect. So what is that? S1, set 1, and to set class S2. Fine. I just have this with a comma. Now when I try to run this particular thing, you can see it is showing only the information which is common in both. What is common in both? 3 and 4 is common in both. Showing only the values which is common in both the things. So this is your intersect. Intersect is the information which is common in both. It is going to be displayed only that values. Fine. So we use the ampersand symbol to represent the intersect. Now the same way, we do also have a difference. A difference is I want to see the data of one set. I want to exclude the data of the second set, and even the common information I want to exclude. That is where we use a difference. So difference, we use a minus, shows the data from the first set excluding the common data. So that means it shows only the data of the set 1. The second set data will be excluded, even the common information will be excluded. Fine. So it will be written like this. Print. What is the difference? So in this case, I just say S1 minus S2. So when I run this code, you can see here the difference is. So that means it is showing only the data of. It is showing only the data of the first set. Okay, it is excluding the data of the second set, and this also the common information. What is that? 3 and 4, which is common in both. That also is not shown. So only 1 and 2 is been shown. That is the difference. What it is. Fine. Apart from that, in Python, we have this thing here called as symmetric difference. Okay, what is this? So we use with this exponent symbol. It's uncommon data from the first set, excluding the common data. Okay, so let us see this symmetric difference. I just say this exponent. You can see here it shows 1, 2, this one. So only the common, see it is showing the data of the first set as well as the second set. The common data is not shown. So that is what is your symmetric difference. So and we use this particular symbol to represent the symmetric